Woman JK, well, welcome everyone to this afternoon's panel discussion on learning to program in the Bootcamp2Studio model. My name is Julie Porteous. I'm an Associate Professor in Artificial Intelligence in the School of Computing Technologies here at RMIT. Before we start, I would like to acknowledge the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nations, on whose unceded lands we conduct the business of the university. RMIT University respectfully acknowledges their ancestors and elders past, present and emerging. And while we conduct our work remotely, I want to pay my respects to the wider unceded lands of this nation. Now, over the past 18 months, you've probably heard people say, you know, how would we have coped with the COVID-19 pandemic without technology? And it's true, computer science and software engineering have made living through the pandemic much easier. If you imagine throughout other global pandemics like the Spanish flu in 1918, there were no computers, smartphones, Netflix or Zoom, all the things that have allowed us to stay connected over the last year and a half. We've met each other via Zoom, watched performances online, consulted with our doctors via telehealth, and for people who work in offices, we've managed to keep working at home throughout the lockdowns. So it's clear that computing has helped people in many unexpected ways. And recently, here at RMIT, we have revamped the way in which we teach programming, a fundamental skill, in the first year of both the computer science and software engineering degrees. We've adopted a unique learning and teaching approach that we call the Bootcamp2Studio Model, and that's transformed the student experience. So today, to find out more about that, we have lined up a fantastic panel, which includes academics, an industry professional and a current student. So to get things started, I am going to hand over to them one at a time to introduce themselves. So if I start actually on my right, I'll go in order with Tim. Would you like to kick things off, Tim?
Yes, good afternoon. My name is Dr. Timothy Wiley. I am a lecturer here at RMIT in School of Computing Technologies, and I was on the leadership group that helped develop this model. I'll be taking you through what we're doing here today, and I'm also currently teaching the studio proportions. Thanks,
Tim. And following around in order, Nicole, would you care to introduce yourself?
Hi everyone, I'm Nicole Abiad and I'm a first year student studying the Bachelor of Software Engineering. And yeah, we're looking forward to letting you know about my experience so far.
Thanks. And last but not least, Anurag.
Hi everyone, Anurag Soin, Director of Data Science at ANZ Banking Group. I'm also fortunate to be associated with RMIT Industry Advisory Committee, actively working with all these amazing people on the call to shape the future of education. And I'm really excited to be here.
Great. Thanks, everyone. Welcome. And thanks very much for taking part today. Now, just before we start, I'd like to remind everybody who's joined us today that we'll have 15 minutes at the end of the panel discussion to go over any questions that you might have from the audience. You can submit questions using the Q&A tool that you find on the right of the screen at any time. And then at the end, we'll do our best to answer as many questions as possible during the session and, you know, follow up if there's not, take things offline if there's not sufficient time. So to get things started, the first question to you, Tim, why did we need to change?
Yes, so it's fair to say that the way in which we work and study has been changing over time, and not just through the pandemic period, but in the computing science area, computing and information technologies, it has been changing for many years. And we've seen that the traditional lecture model is a little bit less engaging for students, along with perhaps some of the more traditional forms of assessments in terms of exams. Whereas what industry is really demanding of us is a more authentic learning and assessment experience for our students. And so over the past few years, we have been developing and putting into practice this Bootcamp2Studio model, where we really want to focus on a skills-based approach to computing, where we are developing the practical skills of our students and focusing on the skills that they need to develop at that core foundation of programming as they then head across from their first year into their second and third years of study. We have seen in industry where boot camps and hackathons have shown that people are able to learn these core programming skills in a focused model, build up that foundation where they can then transition into a project-based approach. And so this year, we launched for the first time the Bootcamp2Studio Model, where we introduced our new students to this approach.
Great, thanks.
Yeah.
Thanks, Tim. So staying with you, good point there to follow on with them. So you mentioned that about the Bootcamp2Studio model. Can you describe to people what you mean by that and the details of the model?
Yes. So the traditional view of a semester of study from a student, which is not shown on these slides, where you would have 4 courses of study, 4 independent silos, and you would take those 4 courses over each semester. This year, we launched this new structure where instead of doing that 4-course approach, students start at the very beginning of their first year with a boot camp, a 4 to 5 week focused boot camp where all you do is focus on learning how to code. That is the absolute core and most fundamental skill that all computer scientists and software engineers need. And so it's a very focused model. After that first 4 to 5 weeks, students transition into a programming studio where we build upon that core foundation of programming and we look at a project-based studio, hands-on and practical exercises where we explore the end-to-end of software development, where we look at how to build software. Parallel to this, students also learn core mathematics skills which are required to be able to take on computer science and more technical details, both in first year and in their future areas of study. This new model is able to break down what we would call the traditional silos of that first year experience, where you would traditionally learn to program and then do a couple of other things along the side. So instead, through this model, we are able to bring students into this exploration of building software that breaks down these silos, where you would look at the front end of user development in this first semester, the back end, and build this into a project that is far more refined than what we would traditionally see out of a first-year teaching model. And we repeat that in the students' second semester of study, where once again they go back into this boot camp and they learn the structure of how to solve coding problems in that focused boot camp model, building upon the skills from the first semester. And again, transitioning into a project-based workshop where we explore how to structure computer systems in parallel with, again, key mathematical skills of statistical analysis. This studio model we have found as we've rolled it out for this first year of delivery has really helped to build students' broad understanding of the whole computer science and software engineering industry in this more practice-based learning method. So, yeah, and if by all means, if you have questions about this, please ask them along in the chat. So I hope that's a fairly comprehensive state. There's a lot to take in there, and I'm sure we'll talk about this more through the panel.
Yeah, thanks, Tim. I mean, I can certainly attest to that. The outcomes, because Tim was leading on one of the studios, and the outcomes from the project and the students completed were quite, well, you know, we've all been, some of us have been in this game for a long time. We're quite amazed at the quality of the outputs that the students managed to produce. So, Tim, let me just follow up with a further question there. So, what do you see as the key benefits for the students from this model?
Oh, yes, and I think to pick up Nicole will definitely attest to some of the work that the students are able to do later on in the panel. But yes, what we see as the key benefits of the students is this holistic semester-based learning outcome. And I know Anurag will talk later on about how industry is looking for students with key sets of skills to make them job ready. And that's what one of the real benefits to this model brings, is this holistic approach to teaching where you're not just fixed in your individual silos, but you see right from day one of the student experience how to build software, a core skill of our areas. And that's really where the boot camps and studios bring in that experiential learning. We also talk about this flipped classroom, where rather than focusing on the knowledge transfer, that is the facts and figures of how to learn a particular area of knowledge, we look at this practiced and focused skill-based delivery, because computing is a skill. The way that I like to describe it to students is it's kind of like learning a musical instrument. or learning to play a sport. You need to practice. Yes, there's facts and figures to music where you learn the scales and the notes and the names of stuff, but really it's about practicing that instrument or practicing that sport. And the same applies to computing. So I think one of those key benefits is that we can have far more hands-on workshop style teaching, which really develops those holistic skills. And as you mentioned earlier, the projects, the outcomes that we get from the students are to an order of refinement that we previously hadn't seen. The projects that students were producing in the first studio were all based around a web application. And I think Nicole would be able to talk to that later on. And we had a showcase of all of the students' work at the end of last semester. And the staff and both industry representatives were very impressed by the quality and refinement that students were able to achieve in their very first semester of study. So I think that very much attests to me what the key outcomes are and the benefits for the students.
Yeah, great. Thanks, Tim. I like the analogy to music there, you know, with the practice. And I think, what is it? You require about 10,000 hours?
Something to that degree, yes.
So it's something like that, yeah. Great. Okay, thank you. If I turn now to Nicole, so we've heard something about the new model, and you're a first year currently in the Bachelor of Software Engineering. You've experienced the model firsthand. Can you tell us something about that and your experience?
Yeah, thanks, Julie. So yeah, I'm in my first year and I've been loving it so far. But just a bit of background on me as well. So I actually finished high school in 2013 and went to study a Bachelor of Communications at RMIT, and then I worked as a publicist for 4 years before I kind of wanted to pursue my interest in computers and software. So I kind of experienced that old model of learning. So it was really kind of good to have something to compare it to. But starting off this year was a little daunting at first, as I'd never coded before. But I was quickly put at ease as soon as we started. So right from the beginning, we're given all the resources that we need, and there's a lot of support from the faculty and teaching staff as well, which is great. But kind of every day of the boot camp, we'd be introduced to a new concept of a programming language. And in our first semester, it was Java, which was really cool. And kind of over the course of the 6 weeks, we developed and deepened our knowledge of the language. And then come the studio classes, as Tim mentioned, we kind of all, as a cohort, had a kind of base understanding and a common understanding rather than learning concurrently, which the old model kind of does, which to me made so much more sense, especially having never coded before. We kind of had upfront all the skills that we needed to begin rather than at the end having all the skills. And yeah, it just made a lot of sense to me. So it was really great to have that base first. And then it also let us go and explore further if we wanted to outside of uni, outside of the classroom. But also in our studio classes, every week we'd build on that in a more focused way that was relevant to our final project, which I thought was really exciting as well. And kind of looking back at the start of the year, it feels like so long ago already. But again, having never coded before, coming from a technical background, it's been so rewarding to see what we were able to achieve, and me personally, what I was able to achieve in just a few short months. So as Tim mentioned, our final project, we worked in pairs to build a website using real world data. And in the studio classes, we learned how to build the databases. We learned SQL, which is database language essentially, as well as HTML and CSS. So all that front end skills that gave to build the website as well. And yeah, it was really awesome to say at the end of the day that we produced this website from scratch, almost back end and front end. And as Tim mentioned, we kind of, we're given all these skills, but yeah, putting it into practice is different when you actually get started. So yeah, it was really cool to see at the end that I was like, hey, I built a website. I wrote that with my partner, and from the front end and the back end. And we also built a database with data that was real, which was really great. So working in pairs too was really important, I think. So probably Anurag can attest to this later on as well, but in software and pretty much any workplace, you're always working with others. So it was a really good opportunity to kind of start that early on and get work with someone else and see what that's like on a project that was completely new. So it was really great to have someone else that we could bounce ideas off and also just learn from someone else. And in my case, my partner had a bit more experience than I did, so it was awesome to have his input when it came to asking questions about Java rather than just going straight to the faculty and stuff, which was always an option as well when we needed to. But yeah, I think that experience was really great and can take that into the workplace. And I think coming into Studio 2 as well for this semester, I think we're working in groups of 4, which will be really exciting. I'll also mention just quickly that, alongside the studio class, we do the maths component as well. I was a bit scared coming into maths because it'd been about 7 years since I'd done some hard maths for me, but I was really surprised at a lot of the concepts that I remembered, and like quickly you pick up how important it is to understand the concepts and the maths concepts, because it just makes you a better programmer. You'll learn to write more efficient programs and helps with problem solving as well. So it worked really well and hand in hand with what we were learning. So yeah, that's pretty much my experience so far, but it's been absolutely amazing.
That's great. It's great to hear, Nicole. I mean, that's what we hoped. But to hear that's your experience of it and your insights. That's great. Thank you very much. So back to you, Tim, if I may. Can you give us an idea of the nitty gritty, if you like, the face-to-face study hours for each of the components, the bootcamp, the studios,
the in and outs, the day-to-day,
and an overview.
Yeah, sure. The learning structure, the face-to-face, day-to-day learning, while it's that you have the focus bootcamp and the studios, it's still a standard study period, the standard study hours. If we want to put numbers on it, we talk about 36 hours or so a week of work, but I don't like to always break it down in that sort of area. So it's not additional work, it's just structured differently. But to help answer the question, I'd like to pick up on a couple of things that Nicole had mentioned. What we really find with these workshops is this hands-on and face-to-face. So what you get in the classes is a lot closer working relationship with your staff members. And that allows us, and I found myself being able to talk one-on-one. I got to know the students better. I got to know their individual personalities, their individual skill sets. We get such a diverse range of students like Nicole, who have come in with a little bit of previous study but never have done any programming whatsoever before, to Nicole's group partner, who was one of those far more experienced students. And we like to be able to cater what we're doing to each of those individual students' needs. And I think that's an absolutely fantastic outcome of what we get there through this sort of flipped model and practice-based approach. And it also allows us to focus on this parallel professional and technical skills. So the technical skills are the coding, the knowledge, the databases, the SQL and stuff like this, but also the professional skills of working in teams, being involved in an industry community, learning to use tools like we have here, online learning methods, team-based remote learning methods, and interactive groups, which is an absolute must of the professional industry every day. So that integration of the face-to-face is, I think, the big outcomes, and that's sort of the experience you'll get on the day-to-day through the class. Yeah, and I'm sure Nicole could speak more to that and her side of the experience and seeing the close some of the working relationships of the daily class.
Yes, and what about the self-study commitment on the part of the students? Could you say something about that, Tim?
Yeah, so that comes back to I think the professional skills that we need to develop. And I'm sure Anurag can attest to this. We've all had experience here. Computer science, information technology is a dynamic and evolving field. So the core of that doesn't change. The core fundamental computer science skills don't change year to year, but the technologies that you use or some of the new algorithms that come out are rapidly developing. To put it in perspective, we're using in the studio technologies that didn't exist when I went to university. And the capacity, so I think the capacity for students to not just learn those core skills, but to learn the professional practice of self-education, self-learning, and professional development is absolutely necessary. And I can see Anurag nodding his head along here. So for me, the self-study is about teaching our students how to take that core and then learn for themselves beyond there, which is what they'll need to do in industry. So the self-study component is helping students develop those lifelong independent learning skills, where you do the knowledge transfer at the beginning. We have preparation material for every class where students learn the facts and figures, and then we come into the hands-on practical class where we put those into practice and perspective. So that's sort of where the self-study comes in, and that's why self-study is important for these skills as well. Yeah.
Great, thank you. One thing that I did want to pursue there was, so you're involved in the development of the model itself, and it was developed in consultation with industry, correct? Can you tell us a little bit
definitely.
about that process?
at RMIT, we have a lot of very close industry connections because of a very industry-focused university teaching approach. We have an advisory panel, an industry advisory committee, and at all stages through the development and also the launch, we went out and talked to that panel at a number of times, and they were always very supportive of the model, very, very keen to get this model and see it underway. And I think from what we've seen in the outcomes of the students, and Anurag, I'm sure you can attest to some of this, the outcomes that the students are achieving have been absolutely fantastic. So all the way along the way, we got advice from the industry, and they were always very supportive of this approach.
Yeah, I will just add to that. And I think probably an image can help there because what Tim said is absolutely true. But I will just add to that. Industry was not just asking for better students or people have more experience. But what industry was looking for is people who can come hit the ground running. RMIT has done that in multiple ways, to be very honest. Like this bootcamp, which we are seeing now, is the work of multi-year process where industry has worked in partnership with all the amazing people in RMIT, where they have gone, we really need people who can come and hit the ground running. And the best part about this program is RMIT has heard. And they have worked with industry to then develop a program where then students can come and hit the ground running on day zero. So I think that's the beauty of this program, and thanks to him and the entire team for working really hard to develop this.
You're welcome.
Yeah, that's great. Thanks, Tim. Well, it neatly segues into asking you some questions, Anurag. So firstly, thank you so much for joining us today. I know you're Director of Data Science for ANZ, so, thank you for finding the time. I mean, would you like to, the floor is yours, just tell us, a bit, what you do, how you got there, your story and how that fits in today.
Yeah, I think I would definitely love to share my story. But the key thing I think after listening to Tim and Nicole, I would like to focus on is this picture, because this summarizes a lot of what we stand for here at RMIT now. In this picture, what you are seeing is, so 4 years ago, I had a challenge. I was looking for talent and I was struggling to hire people because we are looking for people who can go end to end from, as Nicole was saying, correct? People who know a bit of database, bit of front end, can take a bit of data, run a machine learning model and productionize it. Really hard to find these people because you have all these students working really hard on all these semesters, and they have learned a lot of technology, which is slightly old, let's just say 5 years. So basically not many people are using it. But now, by introducing the hackathon 3 years ago, as part of our industry advisory committee, what we were able to do is take all these amazing students, and this was a small experiment which we did. We introduced one subject as part of our RMIT course, saying case study, which is a mini version of this bootcamp. So this bootcamp is 10 times better than what we did before. In this model, what we did is we said, students, here is a problem. Take the Sentinel satellite data, look it over entire Queensland, and you tell me and predict which areas are going to have high yield of sugar output, which areas are going to have low yield of sugar output. People have gone, are we really going to ask students to do this? I'm like, yeah. People who can take the data from satellite image, pre-process it in cloud, build a machine learning model, back-end and front-end, I want to hire those people. And people were very cynical of this idea for me. And many people came back, Anurag, you have unrealistic expectation. No one will be able to meet it. I'm like, let's give it a try. And this picture symbolizes that what is the potential of our students when given the right level of guidance and support. We ended up hiring 20 interns who have successfully completed the challenge. It's not that I want to prove other people wrong, but I believe that people have in them, in the right given support structure, they will outshine. Rather than asking people to write report, let's ask them to write better code. Rather than asking people to go and submit an assignment on a technology which is not in use, better use of time. Go build your GitHub profile, put it out there, share with LinkedIn community, so that when the prospective recruiters are coming, they're excited about you. So that's a bit of a background story. But let's bring it up to what we have done that point of time, which is like a very small experiment, and the success of it you are able to see in the screen. Is what I'm expecting. There are two things, there are two aspects which we have to focus on. First aspect of what is in for the student, and second aspect is what is in for the industry. So let's first focus on what is in for the student. Now imagine, you don't have to actually, because Nicole has said it. You are already first semester student. By the end of first semester, you already have done a project, you already have a GitHub profile. So you are learning the skills which are 100% or 100 times more close to the real world. Because what you are learning is you are learning how to work collaboratively with people to deliver an outcome. You are not learning coding. That's where I differ with a lot of my peers. Anyone can learn coding. Coding is not hard. You are learning how you work with people to deliver an outcome. And the sooner you start learning that, it sets you up for success. Now take example of Nicole. Nicole versus any other student who is in a traditional semester program. After the end of 2 years, how the things will look. Nicole will have bunch of projects sitting in her GitHub profile. She can say, here are the 5 projects or 4 projects I have done, Anurag, over last 4 years. I can show you how these products which we have built are helpful for the customer. I can show you how these solutions scale up. Versus a student who is like, I have amazing grades in my semester exams. Is it a hard question to answer who I will hire? Probably not. I am more inclined to hire people who demonstrate that value of that, yes, I can work with people, I can work with real data, and I can solve business problems. So hopefully that gives you a bit of context that how important this transition is. The second element, which is really, really important, and it goes back to the question which was asked to me, that how I reached here. So when I started my journey into the world of data science, no one was called a data scientist. 10 years ago, there was no title as such where people were called data scientists in majority of organizations. And Tim has briefly mentioned that. Every week there are new papers written, new implementations comes, new algorithm comes. Every day Google Cloud is launching a new service, Amazon Web Service is launching a new service. Imagine if you have to excel in this field, what is the one most important thing you have to learn? Is how to learn fast in an independent fashion and how to engage with the community. And that's exactly what this bootcamp prepares you for, is learn fast and work with the community to deliver an outcome. Why I'm focusing on that? If I think about all the things which I'm applying today in my day-to-day job, 90% of them are things which you learn on job. Because in our days, there was no bootcamp style model. And I would have loved to enroll in a course which has a bootcamp style. So I think students are lucky enough now that opportunity is available. And from industry's perspective, I can put hand on heart and say that it makes it really easy to come and interact at a peer level with student and share. Yes, we work with a similar tool. You use GitHub, we use GitHub, you use Docker, we use Docker. Have you done a bit of React front end? So the conversation is shifting. So I think hope that gives a bit of context around why this model and what does that mean for a student, and why industry is very excited to participate in.
That's great. Thank you. It's really interesting. It's great to have your insights. Thank you, Anurag. Can I just follow up on one thing? Is that you're in the position of hiring and seeing these graduates, and could you say something about the employment outlook in this space for computer scientists, software engineers, data scientists?
Yeah, Oh my God. I will probably give you a bit of context here because I think the economic environment play a very, very big role and the social political environment play a very big role. The moment COVID was hit, what organizations were planning for the journey on going to the cloud or focus on the data, it has fast tracked. So what we could have expected to happen in 5 years has happened in 1 year. Every single person is working remotely. Majority of the work is already happening on cloud. Just imagine we are using a tool now, Microsoft Teams, where it's hosted, Google Cloud or Microsoft Cloud or AWS Cloud. Could we have imagined a world in this scenario where we don't have these resources? Now, who are these people who are building these resources? Data engineers, software engineers, data scientists. Just look at how we have, like how many people used to think about exponential charts and how, just take example of Victoria. How focused are we on data? How many cases are coming? What is the predictability looking like for us to come out from pandemic? A lot of organizations are asking, what is the impact of this on our revenue? So it has bring to the center stage that the importance of data, importance of cloud, importance of software engineer, and the right balance of the people who can deliver these things.
Yeah.
What does this mean? We have supply here, demand here. And that's one of the reasons why I'm here and talking to all of you. Because we need a lot more software engineers, data scientists, as the shape of the economy is changing. We are becoming a more knowledge economy, Australia as a whole. Just see the number of fintechs which are coming out of Australia. The success, the companies which are started in Australia and going across the globe, Atlassians of the world, Afterpays of the world, Zip, like all these companies are now laying down a foundation where we are moving away from a resource-based export economy to a knowledge-based export economy. And as the importance of knowledge-based export economy will evolve further, because in a more digital, more connected world, that pillar will play a very, very significant role.
Yeah.
And I don't think anyone will question us on that.
Yeah, no, I absolutely, I totally agree. Yeah, no, it's great, and insights from your perspective as well. It's great. Yeah, and it's an interesting thing that when you touched on, the impact of COVID, which has obviously been huge on all of us. I'm going to turn to each of you on the panel to ask you about that. So moving to Tim firstly. So the impact of the pandemic. How has that impacted on the way in which you deliver the Bootcamp2Studio model?
Well, I think the observation is the model is very flexible in this, and we always had that in mind, even from the beginning, that even before COVID, companies were already transitioning to more remote ways of working or teams focused throughout the world. You look at the likes of Google, they have offices I have friends who have worked all around the world. In the transition to COVID, yes, I mean, there are impacts, and being at home is hard on a lot of people. However, we were able to adapt very quickly to the online form of teaching. We had an online class to be able to support overseas students right from the very beginning. And then 3 weeks before the end of our semester, we had to switch all of our on-campus teaching back to online, and we were able to do so almost overnight. We went from one day being in person to the next day being, right, we're all coming into an online platform such as Microsoft Teams. So it was necessary, but I think that's an important skill for students to learn. We've been talking about this within the model, that this is the new reality of working, particularly in the software industry, and it's a core skill to be able to work in this format. Yeah. Yeah,
very true. Very good point. Absolutely. So, Nicole, can I hand that over to you? How have you found it on the student perspectives?
Yeah, it was really good. I'm just kind of going to repeat what Tim said essentially, but yeah, we were really fortunate to be in person for face-to-face learning for most of the first semester, which was awesome. But then we transitioned to online basically overnight, and I was really impressed with how it all worked. Every class was really well organized, and I feel like we were still able to get really good interactions with our peers and with our tutors and professors, like as easy as we would in person. Obviously, it's not the ideal where we can, but as Tim mentioned, I'm sure Anurag will say this as well, but it's a really good skill to have regardless, because it is the 21st century and we can kind of work remotely, and it is kind of the future now, especially the past few years. We've been doing it for almost 2 years now, and just means that we can kind of grow that skill as well. So it's another good thing that we can take with us to the workplace.
I mean, if I may pick up on that, one of the reasons for that smooth transition, I think, is we were using these online tools from the very beginning of the classes. So right from the boot camp, and particularly in the studio, we're learning those professional skills. You are interacting with staff and students always online in an online platform from the very beginning. So that really helps with that online setting.
Yeah. I mean, Anurag, over to you. I guess you were already working in this way, but it's forced things on you as well.
So I will probably take a lens of think about this from a perspective that as a team, the way we have tried to play this to is our strengths. We have leveraged existing relationships to then form the buddy system and have people work as pairs. And it's very interesting, the model which RMIT has adopted in the bootcamp style is, because the risk is someone feel they're alone in this. By having a group of 2, a group of 4, you can manage that in a much effective manner, because, oh, I got stuck here, but I have these 4 people. And imagine, even if you're working before, not in a virtual world, in a classroom, but if the projects are pretty much individual focused again, you don't get that learning. So from my perspective, I have seen this play a positive role. The other angle which I would touch upon is it also brings to light an opportunity for people to leverage that delta time which you have and fast track your learning. And it's to my surprise, the level of participation I'm seeing in Melbourne data science community from RMIT students and other university students, it has gone up significantly. So people are not taking this opportunity to go, oh, I have a little spare time. Can I go and connect with someone in the industry? Can I listen to a podcast, or can I be a part of meetup and come to a hackathon? So I think people are really adaptable. And big shout out to all the amazing student community who has very positively embraced this change from our perspective. So
yeah, it's great. Thank you all. So I've got a more general question for all of you. Is this for our prospective students who are watching the session? What advice would you give your younger self as you start on your studies at university? Who would like to go first?
I will go first, because I believe it's really important to explore all the areas which you may like. Don't form views without giving something a try. Software engineering or data science is no longer symbolic to how good I am in mathematics. Those days are gone. We have Python there, which takes care of majority of mathematical computation. If you are someone who can think critically, you can be an amazing data scientist. So don't limit your opportunities, and don't fall in false premise. Give yourself a try. Talk to people around who are in the industry. Reach out to people, and I can bet 99.99% of the people you will reach out in the industry will be happy to help you. And hopefully that will broaden the horizon and the opportunity canvas for every single student. Like, that's what I will expect. So hope makes sense.
Yeah, I'd like to pick up on that. Also, go on, Nicole, go on.
Oh, I was just going to say, yeah, coming from a student perspective and also having completed a university course previously as well, coming into this one was very different, and I had a lot of plans on how to make it 100 times better. But I think the biggest thing was definitely that you do have time to do your work and to do the work. I remember my first course, probably leaving like my deadlines a bit to like the last minute and stuff like that. But I think I was like, no, I'm going to be organized. So I think the biggest advice I would give to myself is you have the time and the class time to do it. So just do the work up front. Don't put it off. It'll make your life so much easier. But also take, kind of like Anurag was saying, take every opportunity that you get. Don't say no to anything because you don't know where it could lead. I remember in my first course, I did quite a few internships and a couple of them came on the back of offers from my professors, and I ended up getting quite a few job offers from that, and I had no idea that could come from it. And I ended up working in industry that I absolutely loved and that I had no idea was even a possibility to work in. So if I'd said no, I don't know where I would be or where my career before had been. But take every opportunity and be organised with your class time is probably the biggest advice that I would give.
I always like to note that, yes, you always got plenty of time to class, and it's always really important to focus on the university studies, and that's what we're here for. But the biggest piece of advice I give is remember to view university as a whole. And study is important, but so is life. And university has lots of opportunities both inside the classroom and socially with all of your students and all of your peers to make sure you take them on all of those external opportunities as well, and give yourself that nice balance, because it can help to refresh and motivate you to continue to do well in the class. And I think one of the outcomes, transition back to the bootcamp model, is you get to know your friends and your students so much more closely because you're in the workshops, you're doing group activities, you're not sitting there in a lecture on your own with a table madly writing down notes from the chalkboard. But so I think that holistic view of university is a really big and important idea, which I personally would have loved to have reminded myself when I was back in university days.
That's great. That's great. Thanks, everyone. Yes, it makes me think what I tell myself. Nicole, a final question to you, if I may. What would you like to do when you graduate? What's your vision? Huh?
So it's a great question, and to be honest, I don't really know yet. So coming into the degree, I kind of had a strong interest in databases, just having worked with quite a few, just literally from a front end perspective in my previous career. But I always, kind of had an interest in how they worked, and we're really fortunate to learn a lot about them last semester, which I really enjoyed, and it's still something I'm quite interested in, but I also really love learning about front end. So there was just so much that we did last semester that I was like, oh, there's this and this and this. And I think going back to what Anurag said, it's like, don't limit yourself to what you can do. It's such a new industry for me, and there's so much to learn, and we've learnt so much already I'm just excited to see what comes up. And I don't really want to limit myself yet, so I don't really know what I want to do when I graduate, but there are definitely companies that I admire that would be amazing to work with, but don't really know where it's going to take me yet, but I'm just excited to see what else is there.
Finding the unmute button. Yeah, no, that's great. And I guess following on from what the advice, that like Anurag and Tim were given, we wouldn't expect you to come out and say, I am going to be this when I finish, because, well, there's so many possibilities and opportunities. Yeah. Excellent. Well, thanks, everyone. Thanks very much. At this point, I'm going to turn to some of the questions that have been posted from the audience, and I'll, hand those over to you, really, the questions, looking down. So the first one, this is a thing that's interesting, and I'll direct this at Tim, actually. What programming languages do the students, are they exposed to in the model?
Yes, we have programming students. So two points on this. Firstly, and I know Anurag will attest to this as well, when it comes to learning stuff for industry, at the end of the day, the programming language matters a little bit less than knowing how to program. And so we focus really on that. Can you learn to program in any language, full stop? And that gives you the big skill set to then learn new languages as you go through your degree and they come out. But it's a very popular question, everyone wants to know, and it makes sense. So in the first semester in Programming Bootcamp 1, you learn Java. It's a very commonly used, one of the top languages still in industry, so we teach you the Java programming language. You then do a project in your Software Studio 1 around Java, so it's written in Java. You build a simple Java web server. But because it's web, you then learn web skills. So you learn a little bit of HTML and a little bit of CSS along the way. And because that website is powered through a database, you learn a little bit of SQL skills and database programming skills. So there's a lot of technologies that you build in that very first semester. In the second semester, students come in to learn Python. And we focus more on what we would call data structures and algorithms, how to represent and structure code. And that transitions then into their project for second semester, which is focused around embedded systems. So students will be working on low-powered embedded systems using their Python code, and I believe even transitioning a little bit into Minecraft and using some stuff there. Although I don't want to give too many spoilers away, Nicole's just about to start.
Well, I've also got a question related to that I'll get to in a moment. But one of the ones was, and I guess this is directed to Tim and more generally to all of you, is like, firstly, do you need to know how to program before starting? But building on that is, what advice would you give for someone to prepare before starting? And
So I can answer the first part of that question. The Bootcamp2Studio is structured with having no experience in coding whatsoever. In fact, we assume you come in with no knowledge and experience at all, and we teach you everything from the ground up. So you don't need any experience. That being said, if you do have experience, we also like to cater for everyone because we like to challenge our students. So particularly in Studio One, if you've got a little bit of experience, we structure the extension area of the project to challenge you as well and explore new technologies and skills to develop that end. And I know Nicole, as she mentioned before, came in with no programming experience whatsoever.
And any advice you'd give for people to prepare, either Anurag or Nicole?
I'll just quickly jump in here as someone who didn't have any experience. I think, the biggest thing is that, and I'm sure it's been mentioned before, but there are so many free resources online, and especially now being at home, stuck at home for a lot of us, like you have the time for it. So we're on a bit of a semester break currently, and we just finished Bootcamp 2 and learning Python, and just having gone through semester 1, I've just been trying to go online and play games in Python or try and learn a bit more about and just expand my knowledge as much as I can, because it is free and it is online and there are so many good courses. I think like Harvard has their free introduction to computer science course if you want to do that, and there are so many good YouTube channels, so many good podcasts. So just getting ahead as much as possible. But if you don't know where, that's fine, because you do get, as Tim mentioned, you do get everything that you need in the university course. But there are also so many free resources that you can continue to build on those skills and just read and take in as much as you can, because it's not going to do any harm. It's just going to better you and better your understanding, really.
Great, thank you. Can I ask, and there's some questions here about some examples of the specific programming projects, both from the the Bootcamp2Studio model and also from the hackathons. If anybody would like to give some specific examples.
Yeah, so in the studio, which the two projects were structured, we gave students a choice. The first project was structured around the impact of COVID-19 in Australia, and the second was structured around the current state of homelessness in Australia. And so we like to structure our programs. Computing is not just programming for profit. We talk about computing for good. What we're doing here is not just to the benefit of ourselves, but to help the industry at large and to help the community at large. And so our projects were structured around data sets and challenges that help to show how we can better the community through our technology and our application. And if I recall correctly, I think, Nicole, you worked on the homelessness topic. And so we gave students a data set around homeless statistics in Australia, both locally within Melbourne and abroad around Australia. And we asked them to present those in a meaningful way and explore that data set and build a website to help educate people on the scale of homelessness around Australia. On the impact of COVID-19, we gave them the up-to-date latest statistics and said, all right, build a website to help present those statistics to people who might be unfamiliar with what's going on, or people who really want to study the in-depth data. The hackathon, which is a activity that takes place in between the boot camps and studios, so students get to come in and have this hackathon experience. You develop an ideation. We give you a challenge and we say, come up with a product and a solution. So this time around, the challenge was about social media and fake news. Come up with a way to address fake news in social media. And so the students had to come up and challenge themselves with ideas to help the design thinking process, which is a big part of learning to code. Yeah.
And Anurag, could you remind us? I know you mentioned it, but the specifics of the ANZ hackathon, datathon. I beg your pardon.
Yeah. So what we have done is we have focused on leveraging the Sentinel Satellite-2 data. So you take the data, take the images, you process them, and try to predict which areas will have higher rainfall by looking at the cloud, temperature, and other variables. So all the skills which Tim and others have talked about will be useful.
Thank you, Nicole. If I can turn to you, the question: can you what was your driver, or what inspired you to move into this world? Yeah, and I guess a follow on with that is like, how does it feel? Is there many other female students, and and how is that in your experience so far in the degree?
Yeah, I think the biggest thing for me was that I kind of grew up. My dad is an electrical engineer and he loves computers and has always loved kind of hardware and building stuff. So I was kind of always grown up with that, and I've kind of loved computers on a very basic level. It kind of sounds weird, but I've always had that interest there. But when I finished high school, going to kind of an all-girls school, not that this is any representation of all-girls schools, but just when I was there and things like that, we didn't get art wasn't a subject for technology and software, which I know some of my fellow students were able to do at high school. And I kind of always loved comms, and I kind of thought I wanted to go into that. So I went straight into it and absolutely loved it. But there was always kind of this nagging that you really have this passion. Why don't you pursue it? Why don't you pursue it? And I guess kind of last year I was working from home and I could see this huge need for more software engineers and things like that. And I was like, you know what? I think if there's ever going to be a time, this is the time to apply. So I applied and I was lucky enough to get in. And I think this is the right move, because I can see that even if I don't go into as working specifically as a software engineer, there are so many possibilities that this degree can offer that I can already see from doing one semester. So yeah, I'm just really excited at the possibility, because I know that there's so much need and demand for these skills that can be kind of applied anywhere. But I guess, going into any women in the course, yes, I am one, and there are many others that I've met along the way. But I think as well, I was more scared about people my age, not that I'm that old, but there are a lot more, older students as well, which has been really nice, but also guys and girls that have come straight out of high school, which is so nice to kind of, get everyone from different backgrounds, because, it's been really good.
Great, thank you. I'll jump in and speak to that if I may. From my perspective, I've been in programming. I've been in the business for a long time. Certainly for an industry to be in, and it's been absolutely fantastic. And being a woman in the industry hasn't held me back in any way. Having said that, in the numbers of women in computer science and across STEM are something that we're very much as RMIT committing to increase the diversity across the STEM college in general, but there's representation of women certainly amongst the staff and amongst the students. So, and we look to things which there's been some amazing changes at RMIT. So we now have the School of Computing Technologies with a female dean. We have in the STEM college. There's similarly senior women in executive positions. It's certainly the university is extremely committed to increasing gender diversity across the STEM college. So yes, let me move on to some further questions. So over to Tim. Actually, can you say whether there's any plans to roll out this Bootcamp2Studio model for subsequent years further across the school?
So when we were designing this, we looked at the whole of the years 1, 2, and 3 of study of the software engineering. 4 years of software engineering, because you've got the internship in year 3 and then 3 years of computer science. And we decided at the moment that we're going to keep the Bootcamp and Studio model for that first year, that core development of computing and that core foundations of skill knowledge, so that second and third year courses can dive deeply into specialized topics and skills. So the second and third year won't have necessarily the bootcamp structure, but these really specialized courses that build on that broad range you developed in the first semester. Instead, what's being incorporated into the programs are what we call these foundational courses, where students will get to explore ideas across all of the STEM college and field. So one of the first ones that has been introduced is Foundations of Artificial Intelligence for all engineering, science and medicine students, mathematics as well. And though when it comes to the bootcamp and studios, there's been such an enjoyment of what's been seen in our model in computer science that the whole of the STEM college is looking at this bootcamp and studio model across the college as a whole. That's how popular it is in industry.
Thanks, Tim. Thanks, Tim. If I can jump and ask Nicole a question about, it's not all about the study, correct? So what about campus, social interactions, clubs, societies? Have you had any chance for that, or has the pandemic impacted that totally?
Well, it's definitely impacted it in that we can't be in person, but there's still so much opportunity for clubs. So I've signed up for quite a few, which is just really easy online. And one of them is the Females in RMIT Engineering. I think it's called FIRE, which has been really great because they're running events constantly. They have had a few in person, but when we were able to last semester, but most of it has been online. A lot of them have been with industry professionals or kind of guest speakers and stuff like that, but also just really fun social ones. So I've met quite a few women who are in the kind of second and third year. So I've been able to get a lot of advice from them about what's to come, which is really exciting, but also, yeah, kind of just making new friends in the industry, and especially women as well, which has been really, really lovely. And I remember as well from my first time at university, joining a lot of clubs, it's where I made a lot of my friends and stuff. Met a lot of my friends and things like that I'm still kind of in contact with now. So yeah, there's still that aspect of it. It's kind of just moved online, which is really exciting, and hopefully we get to be on campus soon, because the campus at RMIT is obviously very lovely. Yes. I know. And the location is awesome too. So yeah, hopefully we can get back there, but otherwise there's still opportunity to interact with the different clubs, and it's a great way to meet other students, especially older students too.
You could, yeah, that's great. You can see that we have a very short amount of time, and I have one big question to throw at all of you, so keep your answers short. Can you think of a global challenge that can be addressed using computing that you would like to close on? Anybody?
Well, I mean, please go ahead, Anurag.
Yeah, I will take that one because of just the reason at which the sheer compute is expanding. And then you look at Moore's law and you look at the number of semiconductors we are able to fit on a chip. What that has enabled is what was not possible few years ago. Every year that possibility is changing. If you will ask few years, like when word-to-vec algorithm came out, that a machine learning algorithm, GPT-3, will able to mimic human text response or the language response, people will say, you are insane. As humans, we are very, very, very bad in assessing the impact of the exponential technologies and the speed at which they develop. Word-to-vec now, GPT-3 is passing the Turing test.
Yes, yes.
As we have these exponential technologies between blockchain, AI, they will feed on each other to shape new interactions in the world and create new values. Think about where was DeFi a couple of years ago.
Yes.
Blockchain is just a thing which is getting started.
Yes,
So
yes.
I'm a big believer that all these technologies think of a world where IoT is picking up sensor data, transmitting it to the cloud, which is again an exponential technology, processing all of that in AI. So I will believe this ecosystem of exponential.
Yeah. It's all, yes, watch this space, I think. Unfortunately, thank you very much. Unfortunately, we're out of time, so we could carry on talking, but that's all we have time for today. So thank you to the panelists. Thank you everybody for joining us today. Do remember to check out all of the other live sessions on the Open Day platform and register for the main online Open Day event on Sunday, August the 29th. And we hope to welcome you to RMIT soon. Thank you. Bye.